The whole world, nay, the whole universe is made of matter. Everything. You, me, pizza, black holes, puppies, dark matter, everything. But there's also this little thing out there called antimatter. Around the turn of the last century, Einstein was working on the theory of relativity, and other physicists were trying to figure out how the tiniest parts of our universe worked, called quantum theory. This was all done with math. Lots and lots of math. At one point, a physicist named Paul Dirac realized x squared equals 4 has two answers. 2 and -2. This means if, say, matter is the 2, there must be some kind of opposite to fit into the -2. Physicists called this opposite antimatter. The reason you don't see antimatter around is because if it were to pop into existence and, say, hit regular matter, the twos would cancel each other out and disappear in a spectacular burst of energy called an annihilation. You probably know that all matter is made of protons and electrons. Well, antimatter, the opposite, is called an antiproton and a positron. A proton is a positive heavy particle. An antiproton is a negative heavy particle. Electrons are light and negative. Positrons are light and positive. Again, because of their oppositeness, if they do touch, boom, gone. But we'll come back to that. Even though they have these opposite charges, in theory, antimatter should be exactly the same as matter. After the Big Bang, the universe should have created equal amounts of matter and antimatter, according to physicists. But there's not really any antimatter around because in the first second after the Big Bang, all the matter and antimatter in the newborn universe found each other and blah, annihilations galore. All the antimatter disappeared in bursts of energy, leaving behind just matter. No one knows exactly why the Big Bang made more matter than antimatter, but these scientists are making antimatter in their lab to find out more about it.
This facility creates antimatter using the particle beams at CERN. We convert protons into antiprotons.
CERN is the Center for European Nuclear Research. We went there last year, and it's where the Large Hadron Collider lives. This antimatter factory takes protons shooting along the LHC and converts those to antihydrogen, the antimatter version of hydrogen. Then Dr. Birch and his team trap the antihydrogen to study it. We know a lot about hydrogen, so we wanted to see how antihydrogen might be different. But remember, you can't let antimatter touch matter, ever. No air, no fancy containers, nothing that is made of matter. So the scientists use magnetic fields to hold the antihydrogen inside this trap. They use energy.
They behave like little tiny refrigerator magnets, and consequently we basically have to arrange a magnetic field geometry that looks kind of like a bathtub. So the antihydrogen atoms basically sit in a magnetic bathtub or magnetic bottle, but it's really actually physically shaped like a bathtub. It's about the size of sort of a 2-liter Coke bottle.
Oh. The magnetic bathtub is called a Penning-Malmberg trap. The magnetic field keeps the antihydrogen from hitting the walls of the trap and annihilating, because remember, no touch matter. Powerful magnets and lasers force the antihydrogen to get stuck inside the magnetic field, sort of like a piece of candy in a bowl. Once they've trapped the antimatter, the scientists at the factory can learn things about this mysterious mirror of our universe. Disappointingly, antimatter isn't some kind of miracle form of matter. It doesn't have anti-gravity properties. It doesn't do, well, anything different at all. If you could somehow find a way to build a table out of antimatter, it would just be a table. That's weird, right? What if in those few hot moments after the Big Bang, the universe was completely made of antimatter? Would it feel exactly the same to us? I mean, think about it. If antimatter and matter are exactly the same, then what's the difference? If the whole universe was made of antimatter, we would just call it matter. And what we think of as matter would actually be antimatter. All the things we call positive, they're just relative to our experience. All the charges are relative, with our universe arbitrarily being made of matter. Physics gets really weird when you get right down to it. In the end, an antimatter universe based on everything we know would look and feel exactly the same as our own. But more research is needed. Scientists trapped antimatter for the first time in 2010. Now, just a few short years later, they've learned to trap more than a dozen antiatoms at a time over and over and over again. Woo-woo!
Antimatter has been held by experiments here for many, many months. And indeed, one of the experiments has a collection of antiprotons that they grabbed onto sometime early last year, and they've actually still have the same antiprotons that they've had the whole time.
But even still, after a bit, they have to let the antimatter go. Then it annihilates and disappears. But even though annihilation does sound like a big, violent, terrible thing, it's actually kind of like a... The scientists do see some gamma radiation, and then that's all she wrote. Practically speaking, CERN has only made 10 nanograms of antimatter ever. Ever. All the energy from annihilating that could only power one light bulb for, say, 4 hours. And to make that antimatter takes 1 billion times more energy than we get back from annihilating it. There's not a lot of practical applications for this antimatter research yet, but...
Antimatter is actually commonly used in a lot of medical techniques, such as positron emission tomography.
It's also called a PET scan, and it's used for cancer diagnoses. Look, Star Trek famously traveled the universe using engines that ran on matter-antimatter reactions. There's a lot of potential here, but based on what we know of antihydrogen, whether we could do that in the future is a big old shrug. At the moment, almost a century after it was first theorized, antimatter research is still in its infancy. But thanks to Dr. Birch and dozens of grad students and scientists around the world, maybe someday we'll know more. The Antimatter Factory make their antiprotons using the Large Hadron Collider. But do you even know what the Large Hadron Collider is? We went there. Check it out here. It's going to blow your mind. How do you guys feel about physics with no practical application? Boring or incredible? Tell us in the comments. Please subscribe for more Seeker, and thank you so much for watching.